Hey everyone, and welcome to Train Talk. Today's topic may seem pretty straightforward, but it is nonetheless an important subject with regard to railroad operations. In this episode, we will be talking about how trains are turned around on the railroad. There are a few different major scenarios we will be discussing based around the available track layout. We're going to go through all 5 of these basic situations in which a train would need to turn around, how the actual change in direction of travel is made, and finally, the real-world scenarios in which each method would be applied. Let's begin. The first and most basic situation in which a train might need to turn around is if there is just a single track. Looking at this option, it might seem as though there is no physical way to turn the train around. And there isn't. In this case, if a train needed to go back in the direction it came, it would simply have to back up or reverse the direction of travel. In order to do this, a crew member, most likely the train conductor, would need to be positioned at the end of the train to communicate instructions to the engineer and make sure the line is clear. Moving a train in reverse without crew protection is what's called a blind shove, which is against federal regulation. While it might seem like this scenario has no real-world application, there are actually a number of instances where this would come into play. Probably the most common is on commuter or intercity passenger trains. When the train reaches the end of the line, there is frequently no time or space to turn the entire train. So instead, these trains have either a second locomotive on the other end of the train, or in most cases, what is called a cab car, a standard passenger coach that has been modified with an operator's cab. Cab cars allow the engineer to operate the train from the last car rather than the locomotive, which not only allows the conductor to attend to other business, it enables the train to run at the full speed limit rather than restricted speed in the case of any kind of a shove move. For more on cab cars, check out my very first episode of Train Talk. Another real-world application of this situation is on freight railroads. Some local freight trains have long industry spurs they must travel down in order to switch out cars. In most cases, the locomotives will back the train into the spur rather than running engine first. In this situation, the conductor will hold onto the last car of the train and radio instructions to the engineer. In some instances, reverse moves are long enough that freight railroads will use old cabooses on the end of the train for crews to stand on rather than hanging from the last freight car. The railroads have designated these cars as shoving platforms. A third and final situation in which a simple reverse move would come into play would be on a tourist railroad. Most tourist railroads are built on old rail lines that are no longer used for freight or regular passenger traffic. On some tourist railroads, there is not enough space to build the infrastructure to completely turn the train around. Instead, the train crew will perform a protected shove back to the station. A second situation in which a train might need to turn around is if there is a runaround track or passing siding. In this case, there is a short section of parallel running second track. Switches at both ends connect the siding back into the main line. To turn the train around, the crew will pull the train forward and come to a stop either on the main or the siding within the limits of the 2 switches. The locomotive will then uncouple from the train and continue forward past the second switch and once again onto the single track. Next, the switches are thrown and the locomotive backs past its train and the first switch. Finally, the first switch is thrown one more time and the locomotive recouples to the other end of the train. With the locomotive and train together once again, the train can proceed in the opposite direction. This is a fairly common scenario, particularly on branch lines and tourist railroads. The one downside to using a runaround track is that following the runaround move, the locomotive must run in reverse until the train reaches its destination. This problem can be remedied if 2 locomotives are used, with one facing in each direction. As I mentioned, runaround tracks are commonly used on short branch lines that don't have other turning facilities. They are relatively inexpensive to build and take up very little land when compared to some of the other options for turning trains. On lightly used freight lines, runaround tracks are often built near the end of the line. A local freight will travel the length of the branch, switching out all the industries along the way. At the end of the line, the locomotives will run around the freight train and return to a larger rail yard where the train originated. A similar situation can be found on many tourist railroads where space and resources are often limited. Trains run between two endpoints with runaround tracks at either end of the railroad. Locomotives run facing forward in one direction and then in reverse on the return trip. The third option for turning a train around is a triangular-shaped piece of track that is known as a Y. A Y is basically a three-point turn for trains or individual locomotives. It features two pieces of track that come off a main line from opposite directions, known as the Y's legs, that connect together at a switch. A tail track extends past the end of the junction of the two legs of the Y to allow rail equipment to sufficiently clear the switch. In order to turn around using a Y, a train can either travel past both legs of the Y and then back in, or proceed directly into the Y and then back out. Ys are helpful in that they can be used for reversing entire trains at once, although it is relatively unusual to see longer trains being turned in this fashion. They also require fewer changes in direction to complete the reverse move than a runaround track. Of the turning methods, Ys are often the most expensive to construct as they take up a lot of space. Ys used for turning equipment can be found in many different locations. Most commonly, they are built in large rail yards. Typically, freight railroads only use Ys for turning locomotives or special pieces of rail equipment rather than entire trains. However, since diesel locomotives can operate at the same speed in forward or reverse, and only the lead locomotive needs to be facing in the correct direction, freight railroads rarely turn locomotives unless it is necessary. Passenger railroads, on the other hand, use Ys on a regular basis for turning entire train sets, particularly those that do not have cab cars at the end of the train. This is done every day with long-distance Amtrak trains all across the country. Ys for turning these train sets can be found at pretty much every major terminus for the long-distance Amtrak routes. Tourist railroads also frequently use Ys for turning entire trains around, particularly in places where space is not an issue. Both the Durango and Silverton Narrow Gauge Railroad and the Cumbres and Toltec Scenic Railroad use Y tracks at one end of the line for turning excursion trains. In addition to turning rail equipment, Ys can also function as railroad junctions where one rail line joins another. In these cases, the tail end of the Y serves as a secondary rail line that joins up with the first. The two legs of the Y allow any train to proceed through the junction in any direction, creating better operational flexibility. One of the most famous examples of this is Ketty Y in the Sierra Nevada mountains on the former Western Pacific Feather River Canyon route. Here, trains traveling up the canyon from Sacramento, California, can either continue east to Reno, Nevada, or north toward Klamath Falls, Oregon. The balloon track is the fourth option on our list for turning a train around. A balloon track is a large circle of track that is pinched off and connected at one end with a switch. Like the Y, a balloon track can be used to turn either an entire train around or just a set of locomotives. In this situation, a train proceeds into the balloon track and past the switch at the beginning of the loop. Once the end of the train has cleared the switch, it can be thrown so the train can then exit the balloon track, turned completely around and moving in the opposite direction from its point of entry. One of the biggest advantages of the balloon track is that the turnaround can be achieved in one step without stopping and backing up. In fact, depending on the situation, it is possible for a train to enter a balloon track and turn around without stopping at all. Balloon tracks are one of the rarest forms of railroad turnarounds simply because they take up so much space. They are usually only seen in large rail yards, certain industries, or on steep mountain passes, the latter only being used in emergency events. In the case of large rail yards or industry loadouts, balloon tracks will sometimes be used to unload entire trains and send them back in the other direction. This is particularly common with unit coal, oil, and grain trains where one or multiple train sets are used to continuously shuttle bulk commodities from a source to a customer. One example of this is the coal train traffic which runs from Wyoming's Powder River Basin to Roberts Bank in Vancouver, British Columbia for export. Here, both ends of the line have balloon tracks for ease of loading, unloading, and turning the trains. It is not uncommon for one train set to remain in service with a fixed consist and locomotive set for weeks at a time, looping back and forth between the coal mine and the port. Some big city passenger terminals or rail yards also have balloon tracks for turning equipment in between runs in the middle of the day, such as Sunnyside Yard in New York City. Occasionally, tourist railroads also use these tracks for turning their trains at the end of a run. Finally, we come to the fifth option for turning trains on our list, the turntable. A turntable is a section of track that is built onto a rotating deck and placed within a circular pit. The deck pivots from its central point, allowing it to travel in a full 360-degree circle within the confines of the pit. They can turn one or two pieces of equipment at a time in any desired direction and are either powered manually, often referred to as Armstrong-style turntables, or with a motor drive. Turntables were very common during the days of steam on the railroads of North America, and at one time, pretty much every rail yard in the country had a turntable, typically paired with a locomotive roundhouse. While turntables don't take up as much space as a Y or a balloon track, they have limited value in that they are really only useful for turning one locomotive. In the days of steam, it was more important to have locomotives faced in the correct direction. With the advent of modern diesel locomotives, however, typically only one unit needs to be faced forward in the direction of travel, as diesels in a locomotive consist can operate just as easily in the forward direction as they can in reverse. As a result, many rail yards have lost their turntables over the years, with the space being repurposed for other uses. Despite their disappearance on major railroads, turntables are still alive and well on tourist railroads and in museums. In addition to serving a valuable purpose in turning locomotives, they also help teach new generations about important railroad technology from another era. Thanks for joining me for this episode of Train Talk. If you have any suggestions for future episodes of Train Talk you'd like to see, or if you have any thoughts on this video, leave me a comment in the comment section below. As always, a big thanks to all my supporters on Patreon. For notifications every time I post on YouTube, subscribe to the channel and click on the bell. Check out my other social media pages for even more train and railroad themed content, and remember to stop by every Friday at 9 a.m. Pacific time for an all-new railroading adventure right here on the YouTube channel. That's it for now. Until next time, I'm Mike Armstrong. I'll see you down the line. Thanks for watching.